Good afternoon, everyone. Thank you for coming to this 30-minute session on personal healthcare IoT on PCF using Spring. I would like to start off by taking a quick poll, if I could, of the audience. Please raise your hand and keep it up if you would. How many of you have loved ones that take 4 or more medications? How many of you have parents or loved ones that are over the age of 50? Look around. This is why personal healthcare IoT is important. This is part of what we got to look at. Thank you. You may all put your hands down. So my name is Jim Shingler. I'm Director of Engineering at Fuse by Cardinal Health in Columbus, Ohio. Fuse is a Cardinal Health Innovation Center focused on connecting technology with healthcare for the future of health and wellness. My personal domain experiences include healthcare, insurance, financial services, and retail. And my passion is applying leading-edge technology to build sustainable solutions. I'm excited and happy to be here at Spring One, and I hope you guys are all having a great time. This is going to be a fast-paced talk about IoT in the personal healthcare space. And if any of you are implementing IoT, you may find that you face similar challenges to the ones that we see in the personal healthcare space. So, without any further ado, let's move on. What is IoT? Well, before we start off with what is IoT, I'd like to take a look at what Arther C Clarke has to say about technology. The favorite one that I have is the very last law that he has, is any sufficiently advanced technology is indistinguishable from magic. Well, what I'd like to do with this presentation is let's take a little bit of a look behind the curtain and see if it really is magic. So, where did IoT come from? IoT, Internet of Things. Kevin Ashton, in 1999, in a presentation he made at Procter & Gamble, coined the phrase Internet of Things. He had several very important points that he made along the way, but the one that I find most interesting is when he said, the problem is people have limited time, attention, and accuracy, all of which means they're not very good at capturing data about things in the real world. So when I stop and think about that, to me that says a lot about the role IoT has to play when you apply it in the home. It's got to be in the background and it's just got to work. It's got to be non-intrusive. So what is IoT? Well, unfortunately, what we can all agree upon is there is no one definition of IoT. There is no universal definition. Here's a couple definitions from the Internet Engineering Task Force and Oxford Dictionary. So let's break it down a little further. What is a thing? We said Internet of Things. What is a thing? A thing is a sensor, an actuator, or a tag. Sensors tell us about what's going on in the environment. These can be such things as temperature, humidity, weight, blood pressure, glucose. What is an actuator? Actuators do something to an environment. It might be a latch, an alarm, a motor, turning something on or off. And a tag is something that's in the environment. This could be an RFID tag, active or passive. Could be a barcode, a fingerprint, or an eyeball. So I'm willing to bet that each of you uses IoT every day and probably just doesn't think about it. Most of you are probably employed working somewhere. You probably badge in. I badge in every day. My card is the badge. I hit a sensor which unlocks the door. That is IoT. We use it every day. This is not brand new. At Fuse, we have something pretty cool. You see over there, that's one of the people I work with. She's using her eyeballs as a tag to the sensor to unlock the door over on the edge. So one of the things I'd like you to take away from this is it's not new. We've been using it. We probably do it every day. I use my cell phone to adjust the temperature at my house. I have my Withings scale, which tells me, oh, by the way, you took this many steps yesterday. Here's your BMI. Here's what the weather forecast looks like for the day, and then sends my weight up to the cloud, which then is available on an application. We've got, many of us have our fitness apps where we track information about when we go on a ride or a run that collects that data in the form of a GPS and sends it up to a cloud. We have Tide buttons, which are absolutely amazing, right? You push this little button and in a couple days, Tide shows up at your house. Many of us have iWatches and such that are automatically collecting data. So if we look back to what Kevin Ashton had said, and I said how I see it playing into our lives. This is some examples. These things are working for us in the background, collecting data and making it available for our use. We even have Siri and Alexa that we can tell them, hey, please turn down the lights in the house. These are some really amazing things. But it isn't science fiction. It's here today. We've got over there on the side, you'll see a pulse oximeter, glucometers. We have our step trackers, our smart scales, and our smart blood pressure cuffs, all to help us and collect information. So these things are all here today. It's real. So these are what we see on the front end, but there has to be a back end that goes with it. So who are some of the players and potential partners in this space? Well, we've probably all heard of Amazon IoT by now. This is Amazon's IoT offering on their cloud. We've got IBM with the Watson effort and the IoTF that's Bluemix, which is actually built on top of Cloud Foundry. We've got the GE Predix solutions, which once again are built on top of Cloud Foundry. And my personal favorite, Pivotal Cloud Foundry. One of the reasons I like Pivotal Cloud Foundry is I really like the way they think about some of these things. They view IoT as the new normal made possible by the mobile revolution, inexpensive sensors, and the falling costs of computing and storage resources. These trends provide the ability to analyze and react to relatively large amounts of data in near real time. I also like one of the quotes they had in there about, from Timothy O'Reilly, that he argues that collectively we are underestimating the impact of IoT, citing its potential to disrupt age-old industries like healthcare. So that's where I sit there and I look at, so what is healthcare? How does this relate to healthcare? Let's take a look at personal healthcare. So this was a really shocking slide that I found from Pew Research Group. And let's take a look at it from the bottom up to the top. So we've got the silent generation and boomers. So depending on how old you are, that may be your parents or your grandparents. And we got the Gen Xers and millennials. One of the things you see there is that over time, we're all aging, we're all getting older. And as we get older, that means we start having health problems. We start getting to the point where we're taking multiple medications. We have complex illnesses. We have complex regimens that we need to follow. So just some quick math here. Silent generation, we have 28 million and they're declining quickly. Baby boomers are at 75 million and they started turning 65 in 2012. Gen Xers, 66 million. It's hard to believe it. We started turning 50 in 2015. Rough math, we have 169 million people in this generation that we're talking about. That's a lot of people. Everybody's getting older. Everybody's going to encounter this. Part of our goal is, how do we help people do this better? So CVS Caremark came out with a report in 2013 stating that medical non-adherence, not adhering to your medical schedules, is a $290 billion problem. That's billion with a B. That's a lot of money. The problem is that nobody has visibility to the patient's medication taking habits and the impacts that they have. What if, as a caregiver, I could tell that mom wasn't taking her medication, or she was taking too much or too little? What if I could automatically send my glucose readings to my doctor so that he could see this new medication, how he was scheduled it, how it's impacting me? What if? At Cardinal Health, we believe that this is an opportunity to connect technology with healthcare to provide reliable, relevant information to stakeholders. So who are some of the stakeholders? Believe it or not, some of your stakeholders usually get your caregivers. That's like me to my mom, right? I care about what's going on. You've got your doctor. He's prescribing all this medication, but he doesn't really see the results on it until you come back to a checkup next time. Who knows how long? Is that a month, 2 weeks? How long is that from now? Your pharmacist is involved in this process. He sees you on a somewhat more regular basis and can tell by when you're doing your refills, get some ideas on, are you taking your medication appropriately? But it's still not detailed enough. Your hospitals treat on an episodic event where, if you're lucky, you get a 24-hour call after you get out of the hospital saying, how you doing? So the problem is that we don't have good visibility to what's going on. There are some additional hurdles. There's a difference between compliance and adherence. Compliance means if you're scheduled to take your medication 3 times a day, you take your medication 3 times a day, well, you could take all of it at once, and that's technically compliant. versus adherence, which means taking it when you're supposed to take it. Intervention strategies. How do we help people when we notice that there's a problem? Security and privacy. This is a huge issue. Credit card, we all know what's going on here this week in Vegas. We got all the hackers in town. So you can buy a credit card on the dark web for $15. Medical records are worth $60 on the dark web. Why is that? Well, part of the reason is because it's a lot easier to commit medication fraud with all the billings and insurances. We have legal and regulatory issues that have to be addressed. HIPAA, we've all heard of that if we've been to the doctor. There's 18 points of data in PHI that is defined that we have to protect. 2 that might surprise you is your IP address and device serial numbers. These have to be protected. And if you don't protect them, the omnibus rules put in huge fines. You can have up to $1.5 million per incident. That could put a company out of business. And then the FDA, they're here to help us. They take it very seriously, but they can actually put you out of business. Some of my colleagues here that are here with us today spend a lot of time working on this, trying to keep us out of trouble with FDA. Time won't allow us to explore these in more details, but there is bonus material at the end if you're interested. So how do we do this? Well, basically, the way I see it, IoT is really an extension of some of the EAI patterns that we already use within the 4 walls of the enterprise. We're really extending these services out and making them available in the patient's home. So what are the primary concerns? Well, in our enterprise environments, we're used to having relatively unconstrained networks. We don't have anything to worry about anymore. But when you're in home, you now potentially have constrained networks you have to deal with. You have to look at the volume of data and the actions you need to take on that data. We have to reliably manage things and the data that comes from them. We are extending services to the outside the 4 walls, and we have security concerns to look at. Personal healthcare adds in some of the things I mentioned earlier with HIPAA and FDA. So what does it take to succeed in this area? Well, you have to register and manage things. You have to secure the communications in a constrained network environment. You have to process and persist large amounts of relatively simple data and analyze the data for potential triggers to action. Well, in doing this, we have to look at what does it mean inside the patient's home and how do we get this data out? When you're dealing with IoT, there's basically 4 communication models that you have to look at. Device to device, device to cloud, device to gateway, and back-end data sharing. These models are not mutually exclusive. They can be used in combinations to build solutions. So let's take a look at the device to device. So in this type of scenario, this is where you have 2 devices in the home communicating with each other. Once again, this is probably another area where you haven't thought about it, but many of our home automation systems do exactly this. Such things as our garage door opener, when we press a button, the garage door opens. If you have a fob for your car, that's another example. And even something as simple, many of us probably have Apple TVs. Even your Siri remote to the Apple TV hub itself is another example. The next one is device to cloud communications. To me, when I start and think about this is I think about my smart TV where I'm watching Netflix and I get bored and I go downstairs and I hop on the TV down there where my Apple TV is and it knows where I'm at in my movie and it'll pick up right there. That's an example of where the IoT device is connecting directly to an internet cloud service and relaying that information back and forth. Then we have the gateway, okay? A device gateway connects to the internet and to the cloud services. So it's an intermediary device. This is where we'll have the difference between a short haul communication and a long haul communication. For example, I could have my glucometer Bluetooth paired to a gateway. So the short haul communication happens from the glucometer up to the gateway. Then the long haul communication happens from the gateway into the cloud to relay that data in. The fourth one is back-end data communications. This is an example where the back-end data sharing extends all of these models so that the IoT device and sensor data is available to authorize third parties. So what are some of the components of an IoT solution? Well, let's start by taking a look at some of the players. Once again, we have the patients, the caregivers, the doctors, the pharmacies, the hospitals, and even the device manufacturers play a role in this. Let's start with managing devices and things. In order to have a device in the home, first we need to know about it through some form of registration. This is the purpose of a device registry. Now that we have a device in the home, we need to receive, authenticate, and process information looking for short-term correlations. This is the purpose of the event processing in the application components. Event and application components relay data events to the big data components for long-term analytics and mining. Now that we have the information coming from the solutions, we need to take the stakeholders and we need to inform stakeholders of items that may have been of interest to them. This is the purpose of a push notification service. This is where if my mom has missed her medications, maybe it pushes something to me and says, hey, your mom's not taking her medications. You might want to investigate this. And lastly, we have the stakeholder dashboards. So why can't I have something where I can log in and see how mom's doing on taking her medications? Why can't I have something where I can see my father-in-law's glucometer readings and see that, oh, wait a minute, this medication that this new medication the doctor just put him on is having a negative impact on his glucose readings. So these are basic components that you'll find in almost any IoT type solution. So how does Spring and PCF help us? Well, one of the ways is it provides this outside container. We have the elastic runtimes. We have the Spring Cloud services at our advantage. We have RabbitMQ to help us with messaging if you're in a messaging-based solution. You've got the MySQL for PCF to help us out for short-term storage, and you got the big data solutions. Your event processor. You have such things up there as your event processor. Your event processor can be a Spring Boot application using Spring Cloud services. Might be using XD or Spring integration, might be using Spring Cloud data flow, and you might be storing the data into a MySQL database. A device registry, if you stop to think about it, is a little more than a Spring Boot application with a storage where you're storing it. Stakeholders, your dashboards, and once again, these are Spring Boot applications. Push notifications, this is an easy one. This is where we've got a component in PCF that they've actually provided for us to help us do all of that. And our big data, we've got the big data components that they've created for us out there that we could be hooking into. So this is talking about a little bit at the application layer and looking at how we can trace some Spring framework and PCF into it. There's actually more. When we start building this out, if you're doing REST-based communications, you've got the microproxy gateways that you can put in the front of it in the form of Zool. You've got the service registry that helps the different components find out about each other and talk to each other. There's configuration that goes with them. We're able to plug in configuration server. And one of the most important pieces to it is security. UAA is one of the most important parts of any type of solution. You may find, depending on how you're implementing it, you may find this as an SSO for PCF, or running your own UAA server. So in UAA, it's got two components that are really pretty important for us. OAuth 2 and OpenID Connect. If you have not seen Sri and Philip's presentation earlier yesterday, they gave a pretty good presentation on demystifying OAuth and OpenID Connect. I encourage you to watch their videos when they become available. Some of the parts of an OAuth role, or an OAuth type solution, are as you got resource owners, client applications, resource servers, and authorization servers. A resource owner is the one who owns the data. So that would be my mom's data on how she's doing with taking her medications. The resource server is where that is hosted. The client application, maybe it's my cell phone, maybe it's a website, wants to access that information. So it works together with an auth server to be able to get that information. When you're looking at security aspects of this, you have confidential clients which are able to keep client secrets to do the connection, and you have public clients. So some examples of this might be if you have a web application that you're running, maybe it's a classic model view controller application, a non-SPA application. That would be an example of a client where it can keep a secret. Some would argue that it's confidential. Can it keep a secret? Yeah, but there's more than one person who knows about it. Public clients would be mobile phones, desktop applications, browser applications. Typically your SPA type applications are also considered public. So in a model, these are some of the models you would typically see with this. You have the web application model where it's a web server running, and it can keep a client secret as it connects to the authorization services. The user agent applications, I like to think of these as your classic SPA, single page applications. The user agent might be, for example, a JavaScript application that runs in the browser. While the JavaScript application is persisted on the server side, it actually runs in the browser, and therefore the client secret is not really secret. It's able to be hacked. When we're looking at healthcare applications, I believe that the last one is probably the more appropriate, and that's a native application. And in that situation, it runs on the desktop, but it's still considered a relatively public client type. So now that we have talked about the client types, and we said that the service needs to find out about them, the back-end services. So that's where you go. OAuth has client registration. And there's a lot of different things you can do with OAuth to find things out. But the most important one is really the client registration. This is an example of registering a client to a back-end auth server. So we have 4 different auth types, that grant type flows that you'll hear about. From most secure to least secure. You have the authorization code, the implicit flows, the resource owner password credentials, and the client credentials. The OAuth dance, as it's known, the auth code does a series of back and forths. We're not going to have a lot of time to go into the details of this. That's why I encourage you to look at the presentation from Sri and Philip on it. But one of the things I wanted to call out here is Will Tran pointed out something to me. This is a really interesting article that I really encourage you to look at. This is a way of doing the OAuth code flow from your cell phones and tablets and being able to have the higher level security flows. So I encourage you to take a look at this resource and read on how to do that. We have the implicit flows where it's a little less secure, where you're getting your authorization tokens quickly. And then we have the resource owner credit card credential flows, which is a little less secure. The big thing you got to be careful about these flows is you are got to really trust the application that you're giving your passwords to. And this is where you have to be careful. This is where you should only be doing this if this is the official application of whoever you're working with. It's generally dangerous. And then the client, which is basically not secure at all. And you should really only be using this when you're getting basic data. So Cloud Foundry and Spring provide us a lot of really good things. So with that, we've got Spring Boot that we can use, Spring Data, Spring Cloud Services, which gives us our micro proxies, service registries with Eureka, configuration through the configuration server, data flow through the Spring with Spring Cloud Data Flow, XD, and integration. These are all options. I should have put some of the Cloud Stream work up there. And then we've got Spring Security and SSO for PCF. And if you want to, you can actually implement and put out your own UAA out there as well. So in review, IOTF, PCF, Spring Cloud Services, and it's a great start. There's some real opportunity in this space. While I'd love to be able to tell you more details about what we're doing at Cardinal Health around here, legal said I'm not allowed to yet. So we've got some things that we're doing here that hopefully you'll be seeing in a short period of time coming out to help with some of this. So IoT, it's not really new, right? You've been doing this. You just didn't call it IOTF or IoT. It's you really applying the EAA patterns and big data and exposing these to the outside world. Security and privacy are extremely important in this area. PCF and SCS provide some really good PaaS offerings to help us get going on some of this. And elastic runtime and infrastructure is very important. This allows us to scale up and down as our product becomes extremely successful. And they provide the components that we need to build a solution. So now what? Well, I encourage you to learn about SSO and PCF. This is going to be some really important stuff as we build microservices and IOTF out. Or take a look at some of the Cloud Foundry UAA. Learn about Spring Cloud and the Spring Cloud services and investigate Spring Cloud Data Flow and Spring integration efforts that go on there. There's been a couple of really good presentations that have gone on this week. I encourage you to go back and take a look at the videos when they become available. You got the OpenID Connect that was presented earlier yesterday, and yesterday the data science powering apps for the internet. And then going on, unfortunately right now, if you're here, you're not seeing this one, is we got the Spring 4 and beyond presentations that are going on. I've included some resources, additional resources in here at the end where you can find out more about IoT. And I've also included this one link back here as well regarding the mobile app and how to take a look at that. I would like to give a big call out to Will Tran. I did some work with Will, and he was helping me get some of the IoT, some of the OAuth stuff set up in the back end, where we look at such things as when you're building out these patterns, you've got to be able to securely communicate between your microservices as you build this out. Some of the important concepts here include your token relay, that you've got to be able to take and have your token persist all the way down through your communications. There's some really neat things that Will has done out there. I encourage you to take particularly look at the top one he's got up there with the Brixton work that he did. Ralph Mira helped me out a lot. Ken Bistani and his work that he's done with event sourcing. And Oleg, and please don't ask me to pronounce his last name. The one last call out I'd like to put out there is I took some of this and put it together here, if you want to take a look at it, and looking at some of the secure communications and how to set up OAuth, an example of how to set up OAuth in PWS. And you'll see a say hello and a hello service out there. All of this is set up with Eureka in the front end of it, and Zool and configuration service. So to give you some examples of how you might be able to do things. Keep an eye out there. I will be putting more information out there. I'll be releasing an example of a device registry out there. So in closing, IoT can be fun. It's coming. And hopefully we can make our parents' lives, and maybe even our own lives, a lot better in the future. Thank you.